Question 1. The table shows the ages of 3 children. The sum of 3 children are 30 years old. How old is the eldest child? So in this case, we need to know who is the eldest child. The eldest child is Rick. Okay, so because since W is found in all children, the one we've added the most, which is plus 4 in Rick, is the eldest child. Okay, so we also know that the sum of the 3 children is 30 years old, which means Sally plus Mandy plus Rick is equal to 30 years old. So we know Sally is W, and then Mandy is bracket W plus 2, and then bracket plus Rick is W plus 4, equal to 30. So this means it's 3W plus 6, which is equal to 30, not 32, 3W. So that means if we were to minus 6 on each side of the equation, this will be equal to 3W equal to 24. And then 1W or 1 is equal to 24 divided by 8, and this will become, 24 divided by 3, and this will become 8. So the oldest, if we were to scroll all the way up, eldest child, which is Rick, which in this case is equal to W plus 4, which also means that this will be equal to 8 plus 4, and this will be 12 years old. There we go. So the eldest child is 12 years old. Question number 3. The figure below is formed by overlapping a square BGFE and the rectangle ABCD. AEF is a straight line. The area of the square is 100 centimeters square. Point C is the center of the square and E is the midpoint of DC. Find the unshaded area of the figure. So we know that the square over here is basically 100 centimeter square. And if you were to zoom it in, C is the midpoint of this center of the square, and there is the shaded part. That's what we see over here, right? So in this case over here, we can actually say that this shaded part over here is actually 1/4 of the square. So we can say shaded part in square is equal to 1/4 of the square. So since we know the shaded part is 1/4 of the square, then what we can do is shaded part in the square, or can actually just calculate it. 1/4 of the square is basically 1/4 times the square, which is 100 centimeter square, and this will be 25 centimeter square. Since this part C over here, right, C is the middle of this square, so we know that this line over here is actually the same as this rectangle line. So they are literally the same. So you see C to B, this is the same as the breadth of the rectangle. Then the thing is that since we know that the E is the midpoint of DC, which means this is technically half of the rectangle. Then at the same time, if this is the same as this over here as well, which also means that this part over here is also the same. So we have the same length and same breadth. So which means this is also the same, and this is also the same. So technically, in this case, we have equal parts of the, or equal lengths inside this square and rectangle, which also means that this 25 centimeter square is also this, I would say, unshaded part. So if you look at the image over here to find the unshaded area, so unshaded area is basically equal to, if you were to count the number of unshaded, I would say unshaded triangles, what would that be? What would be the number? So if you were to count 1, 2, 3, 4, and 5, so this will be 5 unshaded triangle. So since we know the shaded part is basically 25 centimeters square, which means 5 times 25, and this will give us 125 centimeter square. Right, there you go. Question number 4. ABCD is a trapezium. AB is parallel to DC, and XY is a straight line. Find angle CDY. So in this case, if we were to zoom this in, so in order for us to get angle CDY, which is in red over here, what can we do? So angle CDY is actually inside this triangle over here, which is triangle CDY. So angle CDY, basically 180 minus angle DCY minus angle CYD. So which angle can we find out first? So we can find out angle CYD. The angle CYD over here, which is basically this angle. Let me put this in blue. So angle CYD over here will be equal to 180 minus 90 minus 53. And this will give us 37 degrees. Okay, because they are angle in a straight line. So now the next thing is, since we know angle CYD, we want to find the last angle, which is, I'm going to put in green, DCY. So you see over here. So how do you find angle DCY? So we know that AB is parallel to DC because they are a trapezium over here. So AB is parallel to DC. Okay. So essentially, we want to know what is the angle DCY. So from the trapezium angle DCY, basically 180 minus the other angle, which is this angle ABY. So angle ABY cos they are adjacent angles in a trapezium. That's what you see over here. So in order for us to get this angle over here, angle ABY, so angle ABY is inside this triangle ABY as well, right? This green triangle. So angle ABY is equal to 180, then minus 53, and then minus this other angle, which is, I'm going to zoom this in, this orange angle, which is BAY. So angle BAY. So I see over here. So angle BAY is in orange. So that means angle BAY will then be equal to 180. Since this is a angle straight line, we minus 122, and this will give us 58 degrees. So I see over here. Since we know angle BAY is 58, then we actually can get angle ABY, which is in green over here. So angle ABY is equal to 180 minus 53 minus, since you know BAY, this is 58. And this will be equal to 69 degrees. Okay, since we know ABY is 69 degrees, then we can finally find angle CDY. So angle CDY is equal to DCY. So we know DCY. Sorry, before that, angle ABY. We need to find ABY over here. No, we already know ABY. So we want to find this other angle over here, right? So angle DCY is 180 minus 69 degrees because they are adjacent angles in a trapezium. So therefore, we just minus angle 69, and this will give us 111. So now we know this angle is 111 degrees. Then lastly, just need to find the angle that we're looking for. So the angle that we're looking for is CDY. So angle CDY is equal to 180 minus 37 minus 111, and this will give us 32 degrees. Okay, so there you go. So the answer is 32 degrees. Question 5. Some boxes were used to pack 504 plates. Each box contained either 8 big plates or 12 small plates. The number of plates that contains the big plates was twice the number of boxes that contain the small plates. What was the number of boxes used to pack all the small plates? So from the question, it says here the number of boxes that contains the big plates is twice the number of boxes that contains the small plates. So let's use grouping. So one group is equal to, so that means twice the number of boxes, which is 2 times of the big boxes, then plus 1 small. So 1 times small. So can we calculate the number of, so one group boxes is this. We can calculate the number of plates. So one group plates would then be equal to 2 times. So one big plate is 8. So what 2 boxes of plates is 2 times 8. And then plus 1 times the small one, which is 12. And this will give us 28 plates. Since we know one group plates is that, then we want to find the number of groups. Since we know the total is 504, so then we divide this by 28, and this will give us 18. Then that means one group boxes is 2 times big. So 18 group boxes will then be equal to 18 times 2 for the big one, plus 18 times 1, which means this will be equal to 36 big plus 18 small. So therefore, number of small boxes, of small plate boxes, will be equal to 18. Right, there you go. Question 6. Tom had some amount of money. He spent $105 on some markers and spent 1/5 of the remaining money on the thumb pens. The rest of the money was spent on some notebooks. The amount of money spent on the notebooks was half of the total amount of money he had at first. How much money did he have at first? So I drew a model. So we know that we spent $105 on the markers, and then we have the remaining. So the question say we spend 1/5 of the remaining on some pens. So we have one, in a way, units, that is pens, and then the rest of the money was spent on some notebooks. So that means we have 4 units left for the notebook. The amount of money spent on the notebooks was half the total amount he have at first. Okay, so even if you draw this, you might not still be able to solve it. So you need to understand this statement over here. The amount of money spent on the notebooks was half the total amount. So notebooks would then be half of the total. Since we know notebooks is equal to 4 units, therefore half of total is equal to 4 units. That means 2 out of 2 total is equal to 4 units times 2, which is equal to 8 units. So now, can we guess how many markers we have? So since we know pens is equal to 1 unit, therefore markers would then be equal to total minus pens minus notebooks. And this will be equal to 8 minus 1 minus 4. And this will give us 3 units. Since we know markers is $105, that means 3 units is $105 for the markers. And then 1 unit will then be equal to 105 divided by 3. And this will give us 35. Therefore, the total will be 8 units, which is the total. And this is what we are looking for, which is 35 times 8. And this will give us $280. Okay, there you go. So that's the answer. Question 7. Ali baked some cookies. He filled 2 types of cookie tins, large tins and small tins, with the cookies he baked. He filled 2 large tins and 7 small tins with 5 kilograms and 100 grams of cookies. With the remaining cookies, he could not fill another large tin of cookies, and he was short of 200 grams of cookies. Instead, he filled another small tin of cookies and had 100 grams of cookies left. How many kilograms of cookies did he bake? Right, so I've drawn a model over here just to explain a bit about this statement. So with the remaining cookies, he cannot fill another large tin of cookies as he was short of 200 grams of cookies. So the 200 grams over here is the remaining, but the thing is he was short of 200 grams. All right. So in the next statement, it says instead he filled another small tin of cookies and had 100 grams left. So this over here is 100 grams left, and the small tin is what it's can contain. All right. So from here, how do we solve this? So if you were to look closely, right, the thing is that we actually can make this small one into 1 unit. And then for the large one over here, since this is 100 grams, that means this over here is also 100 grams. Okay, so we can say let small be 1 unit. So then that means small is equal to 1 unit, and then the large will then be equal to 1 unit plus how much? So if you were to guess 1 unit plus 100, you're not right, because the large one can contain the 100 grams over here. But at the same time, since it says short of 200 grams, it actually can contain 300 grams. So from here, we can actually calculate this. He filled 2 large tins and small tins with 5 kilograms of 5 kilograms and 100 grams of cookies. So from there, we can say 2 large tins is 2 times of this, right? Large 1 unit plus 300 grams. Okay, or if I say 2 large plus 7 small is equal to 5 kg or 5,100 grams. Okay, so 2 times 1 unit plus 300 grams plus 7 times 1 unit equal to 5,100 grams. If we were to simplify this, it's 2 units plus, it's not 300, 600 grams. Because one large one is 1 unit plus 300. So 2 times of that, if you were to calculate, right, if I were to just duplicate this, 2 large is not 2 units plus 300, it's 2 units plus 600. Okay, so from here, then we need to plus 7 units, and then this will be 5,100 grams. So if we were to simplify this, this will be 9 units plus 600 grams equal to 5,100 grams. We can minus 600 on each side, so we minus 600 grams on each side, as what you see over here. And then this will then be equal to 9 units equal to 4,500 grams. 1 unit will be 4,500 divided by 9, and this will give us 500 grams. So we know that 1 unit is equal to 500 grams. So question is, how many kilograms of cookies did he bake? So the remaining over here, can you guess what is the equation for the remaining? If you guess it's 1 unit, you're almost there. It's 1 unit plus 100 grams. Since you know what's 1 unit, then we can calculate the remaining, which is equal to 500 plus 100. This will be 600 grams. This case over here. Okay, so now we know the remaining. So that means the total will then be equal to 5,100 plus 600, which is the remaining. And this will be 5,700 grams. Or if you were to calculate in kilograms, it's 5.7 kilograms. Okay, so there you go. So that's the answer. Question 8a. The bar graph below shows the ticket prices for the museums. The pie chart shows the number of tickets sold on a Sunday by each museum. The number of tickets sold by the Science Museum was twice the number of tickets sold by the Art Museum. The Toy Museum sold half of the total number of tickets sold on Sunday. How many tickets were sold by the Art Museum? Okay, so from here we know that the number of tickets sold by the Toy Museum, or from the pie chart, it says half, right? So that means toy would then be just half, okay? And then we also know from history, from pie chart, history is 1/4. So that means science plus art is equal to total minus toy minus history, and that will be equal to 1 minus toy is half minus history is 1/4. This will be equal to 1/4 as well. So that means science plus art is equal to history. So which also means science plus art is equal to 258. So now it says here the number of tickets sold by the Science Museum was twice the number of tickets sold by the Art Museum. So science equal to 2 units, art equal to 1 unit. So therefore, science plus art over here is equal to 2 plus 1. That will become 3 units. Since you know science plus art is 258 as well, that means 3 units equal to 258. And then we want to know the art museum, 1 unit, which is 258 divided by 3. And this will be equal to 86. Right, there you go. So that's the answer for question 8a. Question 8b. Which museum collected the most money from the sale of tickets? What was the amount of money? So if you were to look at the graph, we want to see how many gaps before the first number other than 0. So in a way, we are calculating gaps, right? So in this case over here, we have 1 gap, and then we have 2 gaps and 3 gaps. So 3 gaps is equal to $6. 1 gap is equal to 6 divided by 3. This will give us $2. Okay, so now from here, we can actually calculate each price of each ticket. So for art over here, it is over here. There's 1 gap below, what do you call this? 18. So that means art is equal to $16. For toy, it's directly at 12. So toy is equal to $12. And then for history, this is 1 below 30. So this will be 28. So history will be equal to $28. And then lastly, we will have science. So science or science, some people call it, it's equal to 1 below 42. So that means science is equal to $40. Okay, so now we know the ticket price for each. The next thing is we need to know what's the number of tickets. So for art over here, so from the previous question, we want to calculate the number of tickets. So we know that history is 258, art is 86, and then for science is 2 units is equal to 86 times 2. This will give us 172. And lastly, we'll have 6 units, which is toy over here, which is equal to 86 times 6, which is 516. Okay, and then the last one is we are going to amount of tickets sold. So from here, we just calculate for art. We know it's 86 times, and then the art price. Let me put the art price as well on the graph. So for art is 86, okay, times 16, and this will give us 1,376. The next one is let's go for toy, which is 516 times 12, and this will give us $6,192. And then for history, so history total tickets is 258 times 28, and this will give us 7,224. And lastly, science it's basically, so sines we have 172 times 40, and this will give us $6,880. Therefore, what has the highest amount? If you guessed history, then you're right. So answer would then be history with $1,724. Okay, there you go. Question 9. Two rectangular tanks are shown below. 2/3 of tank A and half of tank B were filled with water at first. Water from both taps were then turned on at the same time. Water from both taps flowed out at the same rates of 1 liters per minute. What was the height of the water level in tank B when the water in tank A was emptied out? Okay, so we know tank A is 2/3 filled, so we can calculate tank A volume is 2/3 filled, and this will be 2/3 times length times breadth times height. So length is 50 times 10 times height 45, and this will give us 15,000 centimeter cube. So what was the height of the water level when tank A was emptied out? So time to empty tank A. So we need to convert 15,000 centimeter cube to liters, which is pretty straightforward, is equal to 15 liters. So time to empty tank A would then be equal to volume divided by a rate. In this case, 15 divided by 1, 15 minutes. Okay, so now we know that this is 15 minutes. Then therefore, we need to find volume left in 15 minutes. Or we need to find height left of tank B after 15 minutes. Straightforward. Okay, so first we need to know tank B is half filled. All right, so tank B volume half filled will then be equal to, can look at tank B. So half times length, which is 60, times breadth 20, times height 40. And this will be equal to 24,000 centimeter cube or 24 liters. So tank B volume after 15 minutes will then be equal to 24 minus 15 times 1, right? Basically 9 liters. So if 1 minute is equal to 1 liter, load out, 15 minutes is equal to 15 liters, load out. Okay, so tank B after it was basically 15. Okay, sorry, 24 minus 15, double confirm, yes, it's 9 liters. So height of tank B after 15 minutes then be equal to volume divided by base area. So the volume, in this case, 9 liters will be 9,000 centimeter cube. So it will be 9,000, and then divided by the base area is 60 times 20, and this will give us 7.5 centimeters. Okay, there you go. So the answer is 7.5 centimeters. Question 10, part A. MZY is an isosceles triangle where YZ is equal to YM. WX is parallel to ZY and ZN is a straight line. Angle ZYM is equal to 132 and angle XYN is equal to 97 degrees. Find angle XYM. Okay, so if you find this a bit confusing, what you can do is you can like draw on another part of the worksheet, and then you can just draw one angle at a time. I'm gonna just make this worksheet a little bit invincible. So the thing is that if we were to just focus on this 97 degrees over here, right? Then we actually can get this other big angle over here, which I'm gonna draw in blue. So this blue angle over here, or I call it ZYM. So angle ZYM, which is in blue, is equal to 180 minus 97 degrees, and this will give us 83 degrees over here. Sorry, my bad. So the 97 is actually here. Okay, so 97 is this part over here. Okay, now it looks believable. All right, so 83 degrees in this case as what you see over here. Okay, so now we know this is 83 degrees. Then the thing is, if I were to unhide this, you have 83 degrees on this side. And then we can just highlight the other one, which is 132. So I'm going to highlight it in red so it's easier to see. And what we're finding is this green angle over here. So if I were to make this disappear a bit, then you can see that this 132 is until to this point. So that means to find the angle XYM, it is basically 132 minus 83, and this will be equal to 49 degrees. That's what we see over here. So there you go. That's the answer for question 10A. So for part B, it says circle the words that describe in this statement. WXYZ is not a parallelogram because WZ is not parallel to XY. So we know from the statement over here, WX is parallel to ZY So that's for sure. Wx equal to zy. But we want to prove whether this whole parallelogram, I'm going to highlight it in purple, is a, basically this figure over here, is it a parallelogram? So the properties of a parallelogram over here. So parallelogram has two pairs of parallel sides, as what we see over here. So at the same time, what's the properties of parallelogram? So parallelogram has equal opposite sides, which means angle ZWX is equal to angle ZYM, which is in blue as what we see over here. However, ZWX over here is equal to 85 and ZYM is equal to 83. Since they are not the same, therefore WXYZ is not a parallelogram and WZ is not parallel to XY. Right, there you go. Question 11a. Alice had 580 stickers and Karen had 20 stickers. Then both of them bought an equal number of stickers. As a result, Alice had 5 times as many stickers as Karen. How many stickers did Karen have after she bought the stickers? Okay, so this is what we call a constant difference concept. So what do I mean by that? So for example, if we have Alice and then we have Karen and then we have the difference. So in this case over here, when Alice is like 580 and Karen is 20, so what's the difference? The difference is 560. So the thing is that let's say we have plus 10 on each side, plus 10 on Karen as well. Then what will happen? Alice is 590 and Karen will be 30. So what do you think the difference is? It's actually 560. So this is example. Therefore, if they bought the same number of stickers, the difference is the same. Okay, so now we know that. That means if Alice and Karen difference, so as a result, Alice had 5 times as many stickers as Karen. So that means for Alice over here, it is 5 units. And Karen is 1 unit. The difference is 4 units. So which means 4 units is equal to 560. Okay. And then 1 unit would then be equal to 560 divided by 4. And this will give us 140. And how many stickers did Karen have after she bought the ticket? So after bought or the after. I suppose your after lah. So that means 1 unit over here is actually what is Karen in the after. Alright, so the answer is 140 stickers. So question 11 part B, it's basically how many more stickers would Karen need to buy to have twice the number of stickers as Alice? Since we know how much is Karen, which is 140, then we want to know Alice, which is 5 units, which in this case is, you can either add 560 plus 140, or for me, I'll just use 5 times 140, which will be equal to 700. So this is what we know of Alice in the after. So how many more stickers will Karen need to buy twice number of stickers as Alice? Not Alex, Alice. Okay, so that means twice number of stickers for Alice then be equal to 700 times 2, which is 1400. So how many more stickers would Karen need? In this case, we know that Karen after has 140. So that means it will be 1400 minus 140. And this will then be equal to 1260 stickers. Okay, there you go. Question 12a. Madam City had a box of beads. 65% of the beads were plastic beads and the rest were glass beads. Madam City added 288 plastic beads and glass beads into the box. In the end, 75% of the beads in the box were plastic beads and the number of glass beads was twice the number of glass beads at first. What is the ratio number of plastic beads Madam City had at first to the number of plastic beads Madam City had in the end? So for this percentage kind of question, we know that plastic is to, let me write like this. So plastic is to glass is 65% is to, so glass will be 35%. And then if you were to simplify this, 65% divided by 5, this would be 15 is to 7. Sorry, 13, not 15. 13 is to 7 for the at first. Then it says here in the end, it is 75% that were plastic is to glass. So this is at first. Okay, so we're going to do the same for the in the end. In the end, we would then have 75% that is plastic and the glass will be 25%. So in this case, this will be 1 out of 4. Sorry, 3 out of 1. Okay, so this is plastic and glass in the end. So it's over here. All right, so now the thing is that how do we solve this? Because in between, City added 28 plastic beads and glass beads into the box. So added 28, but we don't know whether this is equal. This is not equal number. Okay, but this doesn't really matter. Okay, so we know plastic glass is 13:7. Plastic glass in the end is 3:1. The next hint was the number of glass beads in the end was twice the number of glass beads at first. So which means that if the glass first, which is in this case 7 units, then glass in the end is equal to 7 times 2, which is equal to 14 units. So which means plastic and glass in the end for this would then be, if we times 14, so since we need the glass to be 14 units, we need to multiply by 14. So this would then be equal to 42 is to 14 for this plastic glass in the end. So now we want to know the ratio of plastic, which is at first is to in the end. So for the plastic at first, we'll scroll all the way up. Plastic at first, we have 13. So this will be 13. And plastic in the end will then be 42. Yep. So therefore, the answer is 13 is to 42. So for part B, 12 part B, we want to know how many glass beads did Madam City add into the box. So the number of glass beads in the end, no. It says here City added 288 to this first. This is added 288 plastic beads and glass beads into the box. This does not mean equal number of plastic and glass beads added. So this is a warning. Okay, so since we know the before and after, so plastic glass, so before it was 13:7, or at first it's 13:7. After is 42:14. So that means difference in plastic or plastic added units will then be equal to 42 minus 13, and this will give us 29. Then for glass added, it is equal to 14 minus 7 equal to 7 units. 2 units here. So plastic and glass added is equal to 29 plus 7 is equal to 36 units. And we know plastic and glass added is also 288. Therefore, 36 units is equal to 288. So 1 unit will be 288 divided by 36. And this will give us 8. So therefore, how many glass beads did Madam City add into the box? So glass added, so 7 units is glass added. In this case, it's just 7 times 8, which is equal to 56. So there you go. That's the answer for question 12B. Question 13A. The graph below shows the number of cakes baked by oven A and oven B. There was an order for 540 cakes to be baked. In the first 30 minutes, cakes were baked in both oven A and oven B. Then oven A broke down. In the next 2 hours, only oven B continued to bake cakes at the same rate. How many cakes could oven A bake in 1 hour? So if we were to zoom it in, we want to calculate the number of gaps. So in this case, 3 gaps go to 12. 1 gap go to 12 divided by 3. This will give us 4. So we need to know how many cakes can oven B bake in 30 minutes. So that means we need to calculate from 8:30 to 9 a.m. This 8:30 is 28 right here, 28, right? So A and B can bake 28, but then after that it broke down. So then B have to take over, and this will be 44. So that means oven B in 30 minutes, which is 0830 to 0900. It's basically 44 minus 28. This will give us 14 cakes. So that means oven B bake 14 cakes. So 30 minute oven B bake 14 minutes, 14 cakes, right? And then we know that 30 minute oven B or A plus B bake how many? 28. That means 30 minutes oven A bake is 28 minus 14. This will give us 14. So that means 60 minutes or 60 minutes. Sorry, my mistake. 44 minus 28 is 16 cakes. So 30 minutes is 16. Okay, so 28 minus 16, this will be 12. So that means 60 minutes or 1 hour of oven A will then be equal to 12 times 2. This will give us 24. So therefore, oven A can bake 24 cakes in 1 hour. Okay, so for part B over here, it says here at what time, question 13 part B, at what time would oven B complete the order of baking 540 cakes? So we just want to know the remaining. So if you were to look at this 10:30 over here, so at 10:30, we just want to know how much is remaining. So at 10:30, it is 92. So remaining will then be equal to 540 minus 92, and this will give us 448. So we know that for oven B, in 30 minutes, he's able to cook or bake 16 cakes. So 30 minutes is equal to, or 16 cakes with oven B will be equal to 30 minutes. So 448 cakes for oven B will then be equal to 448 divided by 16 and then times 30. And this will give us 840 minutes. Or if you were to simplify this, this will then be 14 hours. So that means 10:30 plus 14 hours. Would that be equal to 2430? Okay. So there's no such thing as 2430. It's actually 0030. So therefore, that's the answer, 0030. So question 14, there are 7 small identical rectangles in a large rectangle, ABCD, as shown. The length of each small rectangle is 6 centimeters. What is the total area of the shaded part? So for this, let's zoom this in. I'm going to write here, let L be length and let B be breadth. So for this, we know that the breadth of this rectangle, if you were to look at this, so this is one breadth, and this is one length, right? And this is one breadth as well. See over here. Then on the length side of the big rectangle ABCD, same thing, we have our length over here, another length over here, and we also have one breadth. Okay, so the thing is that if you were to look closely, this is also one length and this is one breadth or two breadth. In this case, one length is equal to two breadth. And we know one length is 6 centimeters, so 1L is equal to 6 centimeters. So therefore, one breadth is equal to, or I could say two breadth is equal to 6 centimeters. One breadth is equal to 6 divided by 2, and this will give us 3 centimeters. Okay, so with that said, we actually can find out the total area of the shaded parts. So the total area of the shaded parts is basically equal to rectangle ABCD minus 7 small rectangles. Okay, so let's get one small rectangle. Pretty straightforward. It's basically 6 times 3, which is 18. Now we can just get 7 small rectangles, which is 7 times 18. And this will give us 126. So now we know 7 small rectangles. The next thing is we want to find the, I would say, ABCD. So rectangle, ABCD, length, it's equal to, so we can see over here, 2L plus B. So 2L plus B, or 1B. So 2 lengths is 2 times 6 plus 3, which is 15. Then for rectangle ABCD, breadth, which is 2B plus 1 length, equal to 2 times 3 plus 6. And this will be 12. Therefore, rectangle ABCD area would then be equal to 15 times 12, and that will be equal to 180. So now we want to minus to get this total area shaded. So it's basically 180 minus 126, and this will be 54 centimeters square. There you go. Question 15a. ABCD is a square and ABR is an equilateral triangle. ABD is a straight line and parallel to RP. Find angle BCR. We want to find angle BCR, which is this one over here. Let me highlight it in red so it's easier to see. So for angle BCR is actually part of this triangle over here, BCR as well. So in this case, angle BCR is equal to 180 minus angle CBR minus angle CRB. Okay, so now the thing is, we also know that ABR is an equilateral triangle. I'm gonna draw another triangle like this. 1, 2, and 3. And we know this is an equilateral triangle. Okay. So, or let me just put the triangle icon aside. And the thing is, since this is an equilateral triangle, that means this is the same side. And since this equilateral triangle side is equal to the length of the square, that means this is also the same. So now we know that BCR is an isosceles triangle. Then the next thing is we can actually calculate BCR correctly. So BCR over here would then be equal to 180 minus CBR, and then we divide it by 2. So we just need to find angle CBR. So do you know what's angle CBR? So since ABC is 90 degrees, and then angle ABR is equal to 60 degrees. So this is side of square, is this part over here. And then ABR is side of equilateral triangle is over here, 30 degrees. Therefore, CBR is basically angle ABC minus angle ABR, right? So with that said, this would then be equal to 90 minus 60, which is equal to 30 degrees. Since we know angle CBR is 30 degrees, then we can find the angle that we're looking for, which is BCR, and that will be equal to 180 minus 30 divided by 2. And this will give us 75 degrees. There you go. So the answer is 75 degrees. So question 15 part B, we are looking for angle CRP. So angle CRP over here is, let me put is in purple as well as over here. So angle CRP is basically in this triangle over here. Okay, so angle CRP then, what are the two angles that we need to minus? So it's basically 180 minus angle RCP minus angle CPR. And we actually know angle RCP. So angle RCP is basically PCB, which is also 90 degrees over here, this, right? And then we minus 75 degrees. So RCP is just minus 90 minus 75, and this will give us 15 degrees. Okay, one down. So this is 15. Okay, so now the next thing is we need to find angle CPR, which I'm going to highlight in orange for over here. Okay, so for angle CPR, it's basically 180 minus, okay, so 180 minus DPR, angle DPR, which is in black. I'll put there as black color over here. Okay, so with this, can we find angle DPR? Yes, we can. So angle DPR, since BD is a straight line across, which is this part over here. So you go across this part, which means this is half of the square. So you see over here. Okay, so that means SDP, angle SDP is equal to 90 divided by 2, which is equal to 45 degrees. Okay, so in order for us to get this, since this BD is parallel to PRP, in this case will look something like this. Therefore, angle DPR is basically 180 minus angle SDP. So now we know angle SDP is 45, which in this case is over here. Okay, so 180 minus SDP because adjacent angles in trapezium DSRP. Okay, because BD is parallel to RP, which also means DS or SD also parallel to RP, makes it trapezium DSRP. So now we know this 45. Let me put in a different color in pink. That means DPR is basically 180 minus 45, and this will give us 135. So see over here. Okay, so now we know DPR is 135. That means we can get CPR, which is in orange. So 180 minus DPR is equal to 180 minus 135. This will give us 45. This then be equal to the orange one. Now we can find CRP. So angle CRP over here is 180 minus RCP and CPR, which is essentially equal to 180 minus RCP is 45, then minus CPR is 15. Sorry, the other way. RCP is 15, and then minus 45, which will then be equal to 120 degrees. Okay, there you go. That is question 15b. Question 16a. The first four figures of the pattern below are shown. The table shows the number of white and gray squares used for the first four figures. Complete the table for figure 5. So let us zoom it in. Okay, so in this case over here, we have a couple of numbers, 2, 4, 7, and 11. So I don't really see the figure over here. I see the numbers, right? So we have white squares and gray squares. So from 2 to 4, it is 2. From 4 to 7, it is 4. And then 2 to 4 is 2. 4 to 7 is 3. 7 to 11 is 4. Okay, so in this case over here, we know that this is plus 2. It is plus 2, then this is plus 3, and then this is plus 4, and then pretty obvious, this is plus 5. Okay, so that means this is 16, right? So 16, so let's see over here. Okay, so nothing too fancy or nothing too difficult. All right, so what about gray squares over here? 2 is to 5 is plus 3, 5 to 9 is plus 4, 9 to 5 is plus 5, something like this. And then that means this over here would then be plus 6. So it'll be 20. So 16 plus 20. So the total number of squares would then be equal to 36. Okay, pretty straightforward. Okay, for question 16b, the first four figures of the pattern are shown below. The table shows the number of white and grays. What is the figure number if there is 144 squares? I see over here. Okay, so in this case, this is a bit hard to see, but essentially, if you have done this kind of question before, it is a number times number concept, meaning 2 times 2 equal to 4. And this will be 3 times 3, which is equal to 9. Then this you can guess 4 times 4 equal to 16. And then 5 times 5 is equal to 25. So we want to reverse this equation to find the figure number. So essentially, figure 1 total is 2. So what we want to do is we actually want to have, for example, 4 would then be figure 1, right? Then same thing, right? So this essentially, if you have done this before, we can actually use root of 4, which is equal to 2. But what we are missing to find figure 1, we need to just minus 1. So if you were to do this for everything, so for 9, it's square root of 9. This will be 3 minus 1, which is figure 2. Then if you do the same for figure 3, this will be 16. Then square root of 16, this will be 4 times 4. So it's 4 minus 4 equal to 3. So that means 144 would then be square root of 144, which is, if you guessed it, 12 minus 1. This will give us figure 11. So there you go. So the answer is figure 11. So part C is how many white squares are there in this figure where the pattern has 30 more gray squares than white squares. So question 16C. So the difference, I'm going to write here, difference. Okay, so difference between white and gray squares. So we have 0, 4 and 5 is 1, and 7 and 9 is 2, and then figure 4 is 3. So I think we see the pattern over here. So difference 0 equal to 1. Difference 1 is figure 2. Difference 2 is figure 3. So how do we get this? So it's basically 0 plus 1, which is figure 1. Okay, then 1 plus 1 equal to figure 2. And then difference 2 is basically 2 plus 1 equal to figure 3. So that means if the difference is 30, and pretty straightforward, difference 30 would then be 30 plus 1 equal to 30. Sorry, 31. Figure 31. Okay, since we know that from earlier, right? Figure 1 total, figure 4 total. So figure 31 total, then be 31 plus, so 31 plus 1 times 31 plus 1, essentially. Okay, so 32 squared in essence, and this will give us a total of 1024. So basically, the difference, since we know the difference is 30, so for the white squares, so if you were to look closely over here, white squares is basically the total, and then we minus the difference, and then we divide by 2. There it is. So in essence, the total is 1024 minus 30, and then we divide by 2, and this will be equal to 497. Okay, there you go. So that's the answer for the white squares. Question 17a. Michael bought 70 packets of muffins and 5 boxes of tarts as presents. There were an equal number of muffins in each packet, an equal number of tarts in each box. The number of tarts in one box is 9 more than the number of muffins in one packet. 60% of the total number of muffins and tarts Michael bought were muffins. How many muffins did Michael buy all together? So from the question, it says Michael bought 17 packets, but the more, I would say, interesting one is the number of tarts in one box is 9 more than the number of muffins in one packet. So what we want to do is let one unit be number of muffins in one packet. So therefore, muffin in one packet will be 1 unit, and then tarts in one box equal to 1 unit plus 9. Pretty straightforward. So the next thing is, we know this thing here, which is 68% of total number of muffins and tarts Michael bought were muffins. Okay, so From here, we want to find the total muffins. Since it's 17 packets of muffins, which is basically 17 times 1 unit equal to 17 units. Then total tarts, okay, is equal to 5 times bracket 1 unit plus 9. And this is equal to 5 times 1 unit plus 5 times 9. And this will be equal to 5 unit plus 45. So the thing is, from here, what's the next step is we need to figure out the ratio in a sense. 68% of muffins and tarts were muffins. So muffins and is to tarts. So we know the total muffin tarts, 68%, okay, is to, so 68 minus 100. So tarts equal to 100 minus 68. This will give us 32%, this case over here. So now we know tarts is 32%. Then we can I would say simplify this. This will be 34 is to 16, and this will be 17 is to 8. And the thing is that we also know that the total muffin also, so muffins unit, tarts unit is 17 units is to how many? 5 units plus 45. Okay, since the ratio, call this normal ratio in muffins and in units are the same. That means 8 units normal are equal to 5 units plus 45. So from here, we can minus 5 units on each side. This will then become 3 units equal to 45. That means 1 unit will then be equal to 45 divided by 3. This will give us 15. We want to know how many muffins? So the number of muffins we have is 17 units. So 17 units is muffins, which will then be equal to 17 times 15, and this will give us 255. There you go. So that's the answer, 255. So part B, find question 17, part B, find the ratio number of muffins in one packet to the number of tarts in one box. Give your answer in the simplest form. So over here from question A, we know that 1 unit is 15. Then earlier, we know how we represent number of muffins in one packet and tarts in one box. So therefore, we were to put into a ratio, muffin in one packet will be 15, then tarts in one box will be 15 plus 9. This will give us 24. Therefore, muffin, one packet is to tarts, one box will be equal to 15 is to 24. If we were to simplify this, we divide by 3 on both sides. This will give us 5 is to 8. Okay, there you go. So that's the answer. So that's about it. If you like this video, give it a thumbs up. If you want more of this kind of video, subscribe down below. Comment down what other things you want me to show you next. In the next one, bye bye.